So, good morning, everybody. I'm supposed to be talking about the GeoE3 integration platform, specifically trying to describe the work that we have been doing in GeoE3 project to set up this kind of integration, dynamic integration platform. Antti already mentioned about the use cases, and I think the energy-related use case is the most important. And based on that use case, we have selected the themes that we have been working with. So buildings, roads, digital terrain model, and digital surface model, and then some climate properties have been in the focus, in the theme focus of the project and of our work. And working with those data sets, those themes, we have been setting up integration platform that connects and integrates content coming from different countries and different organizations. And on the platform, we are working with the OGC's modern service interfaces like OGC API features, coverages, records, and processes. And this platform runs on the cloud platform, which is physically located in Finland. Just a few a bit more technical illustrations about the structure, how it's set up on our cloud service platform. We are using Django as a technical platform for providing those services, and then we have a couple of Django applications that are mostly based on PyGeo API as a generic geospatial software on the platform. And then we provide access to that platform via web service called Apache. And this is quite important illustration describing the idea. In the bottom, you see the services on the national level. So in each of the participating countries, in this case, we have five NMCAs present in the project consortium. We access the national level services that are mostly the legacy web feature service, for example, web feature service or web coverage service implementations. And then on the platform, we connect everything together so that the user will be able to access those country level data sets via this platform, so that the data is requested from the national level service on the fly in real time during the request. And this displays here a buildings theme. So we have buildings data coming from 5 different countries, and those data sets are then seen as collections, as you see here, collection Finland, collection Norway, and so on. They are seen as individual collections inside a single OGC API features service instance. And as a result, we then are able, for example, in case of buildings, we have those collections available at the moment. You see, we have altogether 6 countries present now in theme buildings. And as you see, these are seen as collections inside the service. 3D buildings is an important topic in our project. Based on our selected use case, we wanted specifically to focus on 3D buildings, and we are proud to be able to now serve 3D buildings from all of those 5 participating countries, so that the data sets, the 3D data sets, mostly in case of Finland, Estonia, and the Netherlands, are uploaded to our platform. So the 3D building models in case of those 3 countries are stored on the platform locally. And In case of Spain and Norway, they are accessed from national level. We basically retrieve 2D geometry from the national level services, and then we construct those lot 1 level 3D models dynamically during the query on the platform. As a result, we can get this kind of visualizations from 3D buildings. As you see, buildings from Finland, Netherlands, and Estonia are shown with lot 2 level models. They have real roof forms present in the model, whereas Norway and Spain, we have just lot 1 level models that are actually processed dynamically on the platform. Okay, as a result, we can achieve this kind of visualization like this one here that shows you 2D buildings on top of a map. This happens to be on the border between Norway and Finland. And as you see, we get buildings from both sides of the border river, meaning that we get buildings from the Norwegian local service and from the Finnish service in single request. Then another example is the digital terrain model. We can also get access to this kind of integrated visualizations or data sets even that cross the border seamlessly between Finland and Norway. Another example in the case of 3D buildings, this is on the border between Netherlands and Germany, where we are able to request in one single request 3D buildings from both sides of the border. In the case of Germany, I have to say that we have available only some rather limited test areas because Germany is not part of the project consortium and we do not have access to full coverage of 3D buildings data from Germany in the project at the moment. Climate data is also one important aspect when we are talking about selected use case on energy. And we have been working quite intensively with climate data, meaning long period averages from all of the participating countries. We have been able to access that kind of content from all 5 countries, from their meteorological institutes, mostly as point observations from weather stations that we are then processed to be as interpolated grids, which we serve on the platform via OGC API coverages, meaning that we get a raster kind of output from the service interface on the platform from these climate themes. But we also integrate climate properties to individual buildings on the platform so that we can integrate long period climate averages to individual buildings also as a individual values. Okay, some example of a temperature display from Spain. Again, this kind of integrated visualizations and datasets can be accessed from the lab platform showing temperature in Norway and Finland, for example. Then, as Antti mentioned, we are developing a new version of the platform in the context of a location innovation hub in Finland, where we have, for example, developed a completely new user interface that I will be showing in a minute to you with the help of a professional user interface designer, where we have quite different approach partly to the user interface of the OGC API features and coverages interfaces. For example, the landing page. If you know the structure of those service interface, for example, on the landing page, we have also theme examples available, meaning that we actually connect to service endpoints in a single page. We have developed also a multi-theme explorer that I will be showing to you, and we also seamlessly integrate content across borders so that the themes can be individually selected and contain all the background countries as a single endpoint. We also have now exact coverage polygons instead of the plain rectangles. So this is the landing page of the current user interface. As I said, we have also directly examples of the content themes here. In the bottom you see buildings and roads, for example. So this is a bit more informative landing page than what is traditionally used in the OGC API features service interfaces. This is the Explorer. I will show you it in live demo in a minute. For example, buildings selected, the theme buildings selected here. You immediately see on the map from which areas you get that kind of content available from the service. One more word about the new platform version that we have developed. We now have added a new layer of functionality on top of those original country level collections, so that we can access individual themes from that layer, so that they are already integrated inside the platform. All the background collections from different countries are integrated into a building collection, so that we can access all of those data sets seamlessly. So these are the current URLs. The stable version of the older GeoE3 integration platform can be found in URL geoe3platform.eu. Now the new development version that I will be showing you can be found on that kind of address, and as Antti mentioned, this will be later on published in location europe.eu domain. So as a conclusion, this is dynamic geodata integration platform and specifically designed to be supporting energy-related applications, essentially implementing a new OGC API family of interface standards, features, coverages, where we deal individual countries as data collections inside a single service instance, but also integrate them theme-wise across country borders. And 3D buildings is an important topic here. We provide access to 3D buildings from all 5 participating countries. And those 3D models are provided in city-JSON format via OGC API features, so access interface. And also climate data integration is an important topic, where we process the original weather station related point observations to grid coverages, and then dynamically integrate those climate properties as attribute values to buildings. So thank you for this part. This is Eiffel Tower from Paris, shown in Lot 1 level 3D model.